Hi, welcome to another episode of I Can Alteryx That with coaches Alex and John. I'm John. Today, we're going to cover Alteryx Weekly Challenge number 148, the Rotating Century Puzzle. Let's get started. So we've got a really interesting challenge here. Number 148, the Revolving Century Puzzle. So let's take a look at this puzzle right here. So we've got a series of rings. We've got 1, 2, 3, 4, 5, 6 different rings, and our goal is to arrange the rings, and you can see there's numbers on each of these spokes, so that the sum of the numbers on each of these spokes adds up to 100 for every single spoke. For example, here in the instructions they say, you see this spoke right here, we have 22 plus 7 plus 16 plus 2 plus 18 plus 4 equals 69. So what we have to do is arrange these numbers so that that spoke equals 100, but not all arrangements where one spoke equals 100 will give all the other spokes the same sum. See right here they say, we could rotate the puzzle to get 15 plus 12 plus 13 plus 26 plus 5 plus 29 equals 100. Well then the very next spoke would have to be 20 plus 14, 32, 8, 34, and 6, which gives us 114. You can see here we have our outputs. So here's the first spoke, the second, the third, and so on, all summing to 100. And our inputs are the 6 numbers in each of the rings and their positions. So you can see there's ring 1, ring 2, and so on. So we could probably do this with a macro and make it dynamic and really fancy, but I'm proposing a simpler solution that only requires 11 tools. Actually, it only requires 10, but we'll use an 11th just to make it a little bit easier for us. What I'm going to do is append every single one of these ring inputs to give us one input that contains every possible combination of numbers. So I'm going to append 1 and 2, and I'm going to rename all these. Whoops. I didn't mean to do that. How do I get that? Whatever. Number 1. So I'm going to rename everything number 1, position 1. Number 2, position 2, and so on. I repeat that process for each of these steps. Number 3, position 3. Make sure I don't misspell any of this. And so I don't have to worry about the error on too many appends because the source data set on here never has more than 6, or they always have 6 records. So we don't need to worry about that. So for each level, we're going to multiply the previous number of rows by 6. So the first row is going to have 6. The ring 1 has 6 possible items. After the first append, we'll have 6 times 6, which is 36. I think I made a mistake here. 1, 2, 3, 4, 5. Yeah. Oh no, I just messed up right there. So we're gonna end up having 6 times 6, or 6 to the 6th power rows in our after this final append. Okay. So now that I've done that, I'll drag a browse, connect it, and run. Yep, so you can see here we've got 6, then 36. 36 times 6 is 216. Times 6 times 6, and finally 46,656 possible combinations of different numbers that you can make on this puzzle. So I'm going to just do one thing, and this is not necessary, but I'm just going to arrange all of the numbers and all of the positions so that they're next to one another. I think it just makes it a little bit easier to see what's going on. Okay, so all of our numbers are together, all of our positions are together. So the next thing we need to do is find the column sum. So we're just going to drag a formula tool onto here, create a column called sum, and this will literally just be number 1 plus number 2 plus number 3 plus number 4, and so on. It would definitely be more convenient if this was dynamic and if I transposed and all that, but I don't think it's worth the effort. So you can see here we have all these different sums. So let's go ahead and filter, because we're only interested in where the sum is 100, so there's no point in even looking at column sums that are anything but 100. So by doing that, you can see that there are 650 possible combinations where these columns sum to 100. But again, we have to find the combinations that allow the six different rings to all equal 100 at once. And so what I propose is, let's go back up to the solution, and I'll walk you through how I came about this. Let's just look at this first record right here. 22, 14, 32, 26, 5, and 1. Let's just look at that. So I got 22, 14 right there. Filter this to be 32. I think this one was 26. Okay, there we go. There's our answer. That first solution right there. And let's look at the positions. Position 1, 1, 2, 2, 3, 1. So knowing that this is one of the correct solutions, I know that the other 5 answers have to have the same pattern within their positions. So we can see position 1 and position 2 have a distance of 0. Position 1 and 3 have a distance of 1. Position 1 and 4 have a distance of 1. 1 and 5 have a distance of 2. And 1 and 6 have a distance of 1. And I know that there's only 6 possible places where a number can be, right? There's only 6 numbers, so there's only 6 possible arrangements. So what I'm going to use is the mod function. And if you're not familiar with the mod function, what it is you have a number, n. So if I have a number, say 10, and then you divide it by another number, let's say 6. You see the answer is 4. All mod is taking a number, dividing it by another number, and giving you the remainder. And so what I propose is that we take the difference between position 1 and position 2, between 1 and 3, 1 and 4, 1 and 5, and 1 and 6, and take the mod base 6 on each of those. Now we have to do one extra step because, and I'll explain it in a moment, but if position 1 has a 1 here, well, the distance between 1 and 2 is 1, but the distance between 1 and 6 is also 1. And so we need to account for those two things actually being different. So what we're going to do is we're going to say position 1 minus position 2 mod 6, but we have to do one more thing. I'm going to add 6. So we're going to do 6 plus position 1 minus position 2. That way we're not going to be getting those erroneous matches saying that 1 and 2 and 1 and 6 are the same distance apart. And we're going to wrap this in a 2-string because I'm going to make a 5-digit code or ID that's going to uniquely identify possible position groupings, if you want to call it that. 2, 3, 4, and 5. So we're just going to change this to 3, 4, 5, and then finally 6. And if I run this now, those 650 combinations all now have these unique identifiers. And what we want is to find which of these IDs shows up 6 times. So let's go ahead and drag a summarize tool onto here. We're going to group by ID, and we're going to count how many times each of those IDs occurs. So we can see here that we had 650 sums of 100, but now when we've grouped, there's only 623 different IDs. So that tells us that some of these IDs do happen more than once. So let's go ahead and sort this in descending order. And look at that. ID 05540 happens 6 times. These IDs happen twice, and then everything else only happens once. Meaning that this arrangement of positions yields, in this case, 2 columns that sum to 100. This arrangement of positions yields only 1 column that sums to 100. But our real answer right here, every column sums to 100. So all we have to do now is bring a join. We're going to inner join on IDs. And I'm just going to go ahead and deselect all of our positions because we don't care about those anymore. Actually, you know what? I want to keep this just to show everything one more time because I think that mathematical function I did can be a little confusing. Oh, whoops. I forgot to filter. I want to filter where the count is 6 right here. Now I'll run it again. And you'll see we'll have our answer. So this answer should match what we see above. But let's look at these positions. So again, we have position 1, 1, 2, 2, 3, 1. And down here we have 2, 2, 3, 3, 4, 2. You notice that all of these are incremented by exactly 1 over the first pairing, or the first combination. Then you see down here, 3, 3, 4, 4, 5, 3. Again, we've just added 1 to every position from the last combination. Likewise, we have 4, we have our 5, 5, 6, 6, 1, 5, and then 6, 6, 1, 1, 2, 6. So let's just go back here and deselect everything that we don't need. We don't need our positions. We don't need the IDs or the count. And that will just give us the numbers and the sum. So that should match the output. And there we go. That is how I solved the revolving century problem. Thanks for watching. As always, thanks for watching the video. Don't forget to subscribe to the Data Coach channel for more awesome lessons on Alteryx and all things data analytics and visualization. Follow Data Coach on Twitter at AskTessellation and follow me personally at jemery_dataviz. Thanks again.